There's one more topic I want to cover before we start writing code in earnest, and that's the topic of variables. A variable in C# represents a value. The value that the variable stores can change, but the variable's name will always stay the same. These values could be simple types like numbers or booleans, or they could be complex types, which are typically objects like a customer or a bank account. A variable's value type must be declared, and that's an important word. Declaration is how we tell C# to create a space in memory and what type of value we're going to store in it. Only compatible types can be stored in a variable. So if we're going to declare and assign variables, we must provide two things to the compiler. First, we have to tell it what type of variable we're going to store. And this could be an int, a string, some kind of object, or a class. The second thing is we must give the variable a name. This name, or alias, is what we're going to use to represent the value throughout the rest of the code. When we store a value inside a variable, this is called assignment, and we use the equal sign to assign a value to a variable. So let's review some sample code here, and I'm going to show you what's happening in the computer's memory. In the first line, we declare an integer named myWholeNumber. In the computer's memory, it now allocates a space that is named myWholeNumber. We have not assigned a value yet, so it's undefined, it's empty. In the next line, we set myWholeNumber equal to the value of 1. So now in our computer's memory, myWholeNumber gets the value of 1. In the next line, we decide to change myWholeNumber to a value of 2. So again, the 1 is overwritten, the value is now 2. In the last line, we tell the console to write a line of myWholeNumber. At this point, the compiler would look into the memory and see that the value of myWholeNumber is 2, and it would write out to the console the number 2. Here's some more examples of declarations and assignments. We can declare a byte called small number and set it equal to 5. We can have a string message and put a string value in it. Coding is, of course, very fun. We can have a double value to represent a temperature. In this case, we've declared variables and we've assigned them immediately. We can also declare a variable and assign it at a later time. So when I say bool yes and bool no, it will create spaces for yes and no, but we can't use them until they've been assigned a value. So then down below I've assigned yes to be true and no to be false. So since we have all these types and variables floating around, we often need to convert one data type to another data type. Sometimes we can just directly convert them without doing anything special. This can only happen if the types are compatible. It's called an implicit conversion. So for example, with numeric types, if an integer was to be put into a decimal, that would convert cleanly because a decimal is big enough to hold an integer. But what if we had an integer that we wanted to put inside a short variable? A short maxes out at a little over 32,000, but an int is much bigger. In this case, the compiler would not allow us to put an int into a short because there's a chance that the value of the int would be too big for the short to handle. In this case, we would have to convert or cast the int into a short. This is called an explicit conversion. Lastly, we often want to turn string data into numeric types. This happens in particular when we're reading data from a user. They're going to type something in on the keyboard, and it's going to come to us as a string. So every numeric type has a method on it called parse. And parse will take a string and attempt to convert it to a numeric value. If it can't parse the value, then an error will occur. And let's look at some code real quick here. Here I've created an integer I and assigned it a value of 500. Then I've declared a double called D, and I've assigned it the value of I. So D is now 500. That's just fine because a double can hold an int. In the next line, I want to convert the int I into a short and store it in S. If I'm going to do that, I need to explicitly convert it. And the way C# does that is to put the word short in parentheses. And that's basically instructing the compiler to force the integer to turn into a short. Next, we're going to try to parse a string. So I've created a string variable called myStringNumber, and I've assigned it the value of string 5. That is a string value. I cannot do math on it. It won't have expected results. Remember that if we add strings, we get concatenation, not addition. So if I actually wanted to do math on it, I could take the variable I, which is an integer, and I could set it equal to the result of int.parse and pass the parse method myStringNumber. That would convert the string 5 to the integer 5 and store it in I. Finally, I'm going to show you an example of an error. Here I've created a string variable called notNumber, and I've assigned it the value of banana. If I try to set the variable I to the int.parse of banana, that makes no sense at all and will throw a runtime error when we run the program. Lastly, I want to talk about the var keyword. The var keyword was added to C# in version 3. We're currently on version 5. And it allows you to implicitly type a variable as long as you assign it a value right away. So here's two examples right next to each other of the difference between implicit using var and explicit using the real type. I can say var x equals 10, and 10 will be an integer. I could also say int x equals 10, and x will be an integer. Var looks at the type that you assign it, and it makes the variable that type for you. So it can save you some typing. In the second case, I've said var message equals hi. I could also say string message equals hi. They do the same thing. Many developers prefer using var to explicit typing, but while you're learning in my future examples, I'm going to use explicit typing almost all the time because it's very important to think about your types.